All right, this is a Mikuni SBN 40 or Super BN 40 carburetor. These carburetors are pretty standard on personal watercraft. A lot of Sea-Doos use them, Yamahas, etc. The shape and size changes a little bit. There's different sizes of the hole diameter here, and the mounting base is different. But they're essentially the carbs are usually really similar, and they operate on the same principle. This particular one belongs to a twin set, so it's slightly different. This one has a fuel pump, and the second carb doesn't. But ultimately, same carburetor, different pieces mounted to it. But I'll just go through this, pretending it's just a single here. But they're really similar. So you got your fuel pump side here. You got your metering side here. So this is the side that pumps the fuel, draws it in from the tank, distributes it. It's very important. But it's different than the metering side, which is actually, taking the amount of fuel and delivering it to the carb through the proper jets and where it mixes with the air and goes into the engine. So two different functions here, two different sides of the carburetor, but they're all part of the same body. So starting with a fuel pump, this is how this works. You have a pulse plate, looks like this. It's got a gasket and a clear plastic diaphragm on it. This is sealed, okay? It doesn't let air in or out. The pulse line of the engine is connected here, gives a constant positive pressure, then negative pressure slash vacuum, constantly going in and out. And that lifts this diaphragm up and down ever so slightly. You got your fuel inlet here. So you got inlet fuel coming in from the tank where it goes into this chamber here through this hole. Everything's sealed off here, so fuel is locked into this area. It has nowhere to go. The only thing it can do is go through this check valve, and it can only go one way. So it passes through this plastic flap here, which is a check valve, because this diaphragm is pulling it in, right? It's sucking it in. And then this diaphragm is going to push out as the engine creates positive pressure in the crankcase. This diaphragm is going to want to push, and it can't push the fuel back the way it already came because this check valve is going to lock that out of there. So this check valve is now here in the opposite direction, and it's going to open and fuel is going to go through there. So it's going to draw it in here, push it out here. So it's just constantly cycling fuel between this side and this side. Once fuel gets to this side, goes through here, comes back in here, and it's going to go through these little holes and go over here. And this is where it's going to get used by the carburetor and returned to tank. And then also those ports are in direct communication with this port here, which is the port that's going to pass it into the next carburetor. So that's where all the fuel is going. If this were to sit on the carburetor like this, so you have these three ports here, sit on top of these here. So this is to the next carb, this is fuel to be used by this carb, and this is fuel returning to tank. And you'll see this has a little tiny orifice in it that tends to get clogged up, so that's something to look out for. See that tiny little hole in there? Yeah, those tend to get gunk in them, and that will obviously stop the fuel from returning. So you have a surplus of fuel getting forced into this carb. It's not really what you want. Okay, and now you see this hole here. This hole goes all the way through. It's cast through there, and it's drilled out to just pass right through the other side of the carb. So fuel's going straight through over to this side here. And when the carb's in an assembled state, fuel is actually blocked off. It can't go through there. So if it's in an assembled state, looks something like this. It's got a needle and seat. The seat is something like this with an O-ring on it. Nothing special, just a machined piece of brass. And there's a needle that goes in that seat and seals up that hole. There's a little spring pressure that keeps the needle shut, and a little lever here that will open it up when the diaphragm that sits here presses on this. So that's what allows, you got pressurized fuel from the fuel pump ready to come in, and this diaphragm and what's happening over on this side determines when that's going to come in or not come in. When it So this is the diaphragm that goes over there. This, if you ever see a diaphragm that looks like this, it's a aftermarket piece of junk. Throw it out. Don't ever try to use it because these are always garbage. But anyways, this diaphragm has atmospheric pressure on one side. You can tell because there's a hole in this plate that allows it to vent to atmosphere. So you got atmospheric pressure on this side, but inside of it, you're going to have a negative pressure because of the vacuum pressure of the intake. And as the fuel gets drawn out of there, it's going to pull a vacuum. So vacuum on one side, atmosphere on the other, it's going to actually push on this diaphragm. That's actually going to push on that lever. And then you got pressurized fuel ready to come in the other way. That's going to pop this needle off, and fuel is going to flood inside here, and that's where it then gets metered to its proper jet path. So the fuel is going to enter here through this metering block. Okay, metering block looks like this. It's got 2 bolt holes in this hole in the center. When it goes in the hole in the center, it can go 2 ways. It can come through this check valve and enter one of the regions, or depending on how the vacuum's pulled and so on, there's actually a cross drill here, or it can venture over and go through this hole. And that check valve is there to prevent communication between the 2 jets because it needs to go to the proper jet. So depending on what's going on with airflow in the carb, it's going to draw it into one of those 2 places. So then when it enters into the chamber, like we mentioned, has one route to go to the low speed jet here. So inside there is the brass low speed jet. It will have a number on the side of it indicating the size of the jet. They're usually around like a 70 or something. And then here's your high speed jet. These ones are usually around 130, 140-ish. Those are the 2 differences. So this is a high speed inlet that connects to the high speed adjuster. So you see those are right in line with the adjuster screw here. So this adjuster actually has a point on it that kind of impedes this hole, and that will control some of the fuel flow. And then you also have this properly sized jet that will control the fuel flow for the high speed. And those holes are drilled right straight through, and they actually go into and connect to this little venturi here. So if you get a really good look, you can see in there the hole, actually you can see it goes right through there. So inside that little funnel for air, where it will speed up the air, it will actually draw the fuel right through there. That's the high speed circuit. So that's where that's getting mixed in. And then for the low speed, this low jet here connects to this low speed adjuster, which can impede the flow as the flow goes through here. That can kind of cut some of that off, and that will cut back some of that flow as needed, or unleash it as you adjust that adjuster. But ultimately, these low speed holes, there's one big one here, and then there's 3 little ones right there. Those are the holes where the low speed fuel is coming through. So you can spray stuff through there and make sure fuel's getting through there. They're pretty restrictive, but you should see some fuel go through there, or you could blow air to make sure air goes through there. Those have to be open and clear for this thing to work right, and that's ultimately how this thing is operating.